Hello, I hope you all are doing good. In this video, we will discuss the classless subnetting. We will discuss the problem with the classful subnetting, what is variable length subnet mask, and what is CIDR notation. Also, we will explore a simple network problem, and then we will try to fix that problem. So let's start. What is the problem with the classful IP addressing or the classful subnetting? So as we know, we have different classes in the classful subnetting. Uh, Specifically, we will focus on the three classes, which is class A, class B, and class C. And for the class A, we have around 16 million hosts. For the class B, we have around 65,534 hosts. And for class C, we have 256 hosts. Now, the problem is if I want to create a network of 10 hosts, then the minimum class I can find, or the class which is most appropriate for me, is the class C. And for the class C, I will have 256 hosts. And if I use the 10 hosts which I need, then 246 hosts will be there, but it will not be used. Also, for 100 hosts, I have 156 hosts which will not be used. And if I have a network, or if I want to create a network of 1,000 hosts, then I will have to pick the class B. And for class B, I have 65,536 hosts, but I only need 1,000. So 64,536 hosts will be wasted, or you can say they will not be used. This is one of the problems that we faced with the classful subnetting. And to fix this problem, the solution is variable length subnet masking. Now, what is variable length subnet masking? As you might have guessed from the word variable length. So we don't have a fixed length. So in the classful subnetting, we have fixed length based on different categories, like categories A, B, and C. But here, we can change the length of the subnet mask. So what is CIDR? CIDR is actually a notation, and its abbreviation is classless interdomain routing. And this is the abbreviation of CIDR. Now, we have an IP address of 192.168.10.0. This is class C addressing, as we know. And the subnet mask of the class C is this. And the binary representation is this one. This is all good. But now, we don't want fixed subnet mask. We want the variable length subnet mask. So we have a same IP. This is class C. And the subnet mask is this. And now we are going to borrow some of the bits from the host side. So as you remember, this is the host part. This is the host part. And this whole is a network part or network portion, right? As we discussed in the last lecture. Now, in the variable length subnet masking, what we are doing is we are taking some of the bits of the host, and we are now creating a network of this length. So this is 27 bits. The total, if we count all the bits, these are 27 bits. This is the CIDR representation or the CIDR notation to represent the subnet mask, the variable length subnet mask. Now, what we are saying is the network bits are 27, and the host bits, these are the host bits now. 5 bits are for the host bits. And what is the class? So it's not, there is no class. It is classless. Why? Because there is no categorization based on the classes. So what is the definition? Classless subnetting is done by changing the default mask, and borrowing some of the host bits So in this case, here we have an example that we borrowed 3 bits, and then we say in CIDR notation /27. So 27 is the total number of bits. So it is total network bits. So we can say it is total network bits after borrowing bits from the host, and it's classless. So this is the same example we have, and now this is the binary representation. And with this information, what we can do is we can calculate the number of subnets, what are the total number of subnets, and the host per subnets. So the formula is 2 raised to power subnet bits for the total number of subnets, and for the host per subnet we have the formula 2 raised to power host bits. And in this case we have 2 raised to power 3 because we borrowed 3 bits, so we have total 8 number of subnets, and total number of hosts per subnet we will have 30. We will subtract 2 hosts from per subnet because one is reserved for network as we discussed already, and one is for broadcast. Now let's discuss a simple example. This is a very simple example, and we will try to understand how the classless subnetting works and what are the important points in classless subnetting. So we have a simple network and we have one machine, and the IP address is this one, 192.168.10.101, and the subnet mask is 248. So this is actually /29, right? /29. 29 bits are used for network. And we have a server. We have a server in this one, and we have the IP of 201, and we have a firewall which is 200, or router we can say, which is configured at 200. And this is a simple network which we have configured, but this network is not working, and this machine, the host machine, is not able to send any packet to the server or to the router. Now what is the problem? We need to fix the problem. Now let's look at the problem. So here we have same network, and we have machine IP is 101/29, and server is 201, and router is 200, and we have a subnet mask of 248. Now let's look at the problem. The first binary representation is of machine, the host machine. The second binary representation is server, and the third is the router, and the final we have the subnet mask. So if you look at, so these are the 5 bits which we borrowed, right? These are the 5 bits which we borrowed, and if you look at these 5 bits, you will find a difference that these 5 bits of the machine has a different combination, and the 5 bits for the server and the router, it has a different combination. As we already know that we discussed that this full address is a part of a network. Now this is a network, and this full address is another network, and this is again a network. So this is representing network. So this means the machine is on a different network because this combination is different. Now if it looks like that the machine is configured incorrectly, because, or maybe the server or the router is configured incorrectly, because these two devices, the router and the server, they are on the same network, because as you see, the combination is the same, 11001, 11001. So they are on the same network, but this machine is on a different network because this combination is a different one. This is 01100. So it means the configuration is not correct. So if the machine wants to send any packet, because machine is on a different network, so the packet will not flow as per expected. So let's fix this problem. Now to fix this problem, the network bits should be same. The network bits should be same to identify the network, right? And now what we can do, so if we have a subnet mask of 255.255.255.248, now with this subnet mask, how many networks and how many hosts we can have? So as we remember, the total number of bits we have taken from the host is 2 raised to power 5, and this means we have 32 networks, and the total number of hosts we can have per network is 2 raised to power 3, because we have 3 bits for the host, and this means we have 8. And if we minus 2 IPs, which is one for network and one for broadcast, we will have 6 hosts per network. Now let's look at the first network. The total networks we can create are 32. Now look at the first network. So this is the first network in which we can have 6 hosts, and we will have one IP for the network and one IP for the host. So this is the first IP, and this is the network address, or we can say network IP. And the last is the broadcast IP. And this is the range. These all are host IPs. So host IPs means we can assign these IPs to different devices like laptops, printers, routers, or any other devices. So with this subnet mask and with this IP, we can create total of 32 networks, and per network will have 6 hosts, and 2 IPs are reserved. 2 IPs are fixed. One is for network and one is for broadcast. So this is the first network, right? This is first network. Remember, we can create 32 networks. Now let's look at the second network. The last IP, remember, last IP is .7. Now this is the second network. Now the second network's first IP is the network IP. The last is the broadcast. And this is the range. These are the 6 host IPs. This is the second network. This is the second network out of 32 network that we can create. If you look at the binary representation, this network is now identified by 1. This is also part of the network, by the way. Don't be confused by the green color. This whole is the network portion. This whole is the network portion. And these last 3 bits are the host portion. Now, this is the next network. And then the same way, we can create third network, fourth, fifth, sixth, and it can go up to 32. Because why not more than 32? Because we have this subnet mask, and with this subnet mask, we can only go up to 32 networks. Now let's look at the third network. Here we have, so what we are doing, we are changing the combination of bits, but the important point to look at here is these all these all borrowed bits are same, right? So this identifies that this is the same network. If we will change this combination, so this will change the network actually. So this is the third network, and again same, this is network IP, this is broadcast, and this is the range of host IPs. Now to fix the problem, we have to fix the configuration. We have to fix the binary configuration of our network, and this is the ranges. Let me clean this up. And now we have the first starting from 16. The IP is 16. It will go up to 23. And for the next network, the first will be 24. Now to fix our network problem, we will have to reconfigure our network. Now we have fixed the problem. And how we fix the problem? We have the same binary representation in this network. Now this is our network IP, which is 0. And these are the network, these are the binary representation. So the network IP is all 0. And for the first host, we have 0, 1, and the network portion is exactly the same. This one is same. Here again, we have the machine. We have given the IP of 3, and this is the network portion. And for the server, the IP is 2, and this is the network portion. And now this is correctly configured. Now the machine can send messages to different devices. In the next lecture, we will discuss the classless subnetting. We will take some IPs and we will calculate the network portion. We will calculate the first host, last host, and the broadcast. Thank you.